How's it going, everybody? Got another video here for you. I found this thing online. It's 1869 MIT entrance exam. There's seven questions. 1, 2, 3, 4, 5, 6. Yeah, 7 questions on it. It looks pretty easy if you ask me. I was debating on whether working through the problems or not. I figured, why not? Let's just go ahead and work them and see what we do. So let's look at the first problem. It says if e equals 8, find the numerical value of the following expression. And it's kind of interesting to see how it's typed up and everything. But you can see we've got e minus, and then in brackets, the square root of e plus 1 plus 2. And then that is plus, I believe it's a plus. It looks like a plus to me. Yeah. Plus e minus the cube root of e times, and that's in parentheses, e minus the cube root of e times the square root of e minus 4. So let's go ahead and do this one. This is number 1. I think we'll have enough room here. We've got 8 minus parentheses square root 8 plus 1 plus 2 close parentheses plus parentheses 8 minus the cube root of 8 close parentheses square root of 8 minus 4. And so let's work inside the parentheses first. So we've got 8 minus the square root, that's in parentheses, 9 plus 2 plus 8 minus the cube root of 8 is 2 times the square root of 8 minus 4, which is 4. And so now we've got 8 minus, and then that's going to be 3 plus 2 plus 6 times 2. 8 minus 2 is 6, and then times the 4 is 2. And so then we get 8 minus 5. We don't need the parentheses anymore. 8 minus 5 plus 6 times 2, which is going to be 8 minus 5 plus 12. And then when we do that, we get 15. So first problem, fairly easy. Not bad at all. All right, so let's go to question number 2. All right, second question. And by the way, before you finish watching the video, why don't you pause it and see if you can work all these problems and see how it goes. All right, so we're going to work inside these parentheses first. So we're going to get 3a minus, and then we've got b plus 2a minus b. I'm going to just clear those parentheses there and then distribute that minus a plus b. And so that's going to give us 3a minus, and then let's see, we've got, what do we have? Do we have 2a minus a is a, b minus b is 0, plus b is b. So that's that plus b. Looks right. And so that's going to give us 3a minus b, which is going to be 2a minus b. And there's your answer. So that's not too bad. Pretty easy. All right, let's look at problem number 3. All right, so for problem number 3, I was looking through these problems, when I first saw the test, I looked through the problems, and I looked at this one. It says multiply this times this, and then divide the product by this. So basically what we have here is we have this right here. All right. So when you look at it, you say, okay, well, let's multiply these together and then divide this. Well, when you multiply this, you get something pretty nasty, and then you would go into long division. And, you could do that and everything. But, I got to thinking, well, why not just do this a plus b minus b squared times a squared minus 2ab minus 3b squared. And then why not times 1 over a plus b? And then we got multiplication everywhere, and it doesn't matter what order we multiply in. So that's going to give us 3a squared plus ab minus b squared times, okay, so that's going to be times a squared minus 2ab minus 3b squared over a plus b. And what we notice here is that thing right there factors. And so we got 3a squared plus ab minus b squared. And that's going to be times, and that's going to factor into a, let's see, minus 3b times a plus b over a plus b. And you see here how the a plus b's cancel. And so we're left with 3a squared plus ab minus b squared times a minus 3b. And then this is much easier. So we just multiply the a to each term. So that's going to be 3a cubed plus a squared b minus a b squared minus, and then that's going to be 9a squared b minus 3ab squared plus 3b cubed. And so we're going to have 3a cubed, and then we have minus 9a squared b plus a squared b. That's going to be minus 8a squared b. And then we've got ab squared and ab minus 3ab squared, so that's minus 4ab squared plus 3b cubed. And that's a lot less work than multiplying these two out and then using long division to divide it. So, you know, there's a way to, that's how you can do that one. Let me know if you thought about doing that in the comments. All right, let's look at problem number 4. All right, so now we've got problem number 4, and I know it's kind of, I don't know, it's kind of difficult to tell, but those look like x to the 6 to me. X to the 6 plus a squared x cubed y, x to the 6 minus a to the 4th y squared. So that's what it looks like to me. Let's see if we can kind of get this back maybe a little bit bigger there. Okay, anyway, that'll be good. All right, so now, let's look at this. Well, what I notice out of the numerator, I can factor out a common factor of x cubed, and that's going to leave me with x cubed plus a squared y. And then if we look at the denominator here, that's the difference of two squares. We can factor that, x cubed minus a squared y times x cubed plus a squared y. And we can see those two cancel, and we're left with x cubed over x cubed minus a squared y. And there's your answer. That is an A, not a 9. All right. So that's number 4. We're almost done. Let's look at problem number 5. All right, here's number 5. So, what we'll need to do here is combine like terms in here. Add these two fractions and subtract these two fractions. All right, so to do that, we're going to have a minus b times a plus b. That's our common denominator, plus a minus b, a plus b. Hope I don't run out of room. So this is going to be a plus b times a plus b, and this is going to be a minus b times a minus b. And then that's divided by, and then this is all in parentheses, and that's divided by, and we have a minus b, a plus b, and then we've got minus a minus b, a plus b in parentheses. And so that's going to be a plus b times a plus b, and a minus b times a minus b. All right, so let's multiply out the numerators here. So that's going to be a squared plus 2ab plus b squared over the common denominator of a minus b times a plus b. And then that's going to be divided by, and then we have, oh, I'm sorry. I screwed that up, didn't I? I was thinking ahead. I've got a squared plus 2ab plus b squared plus, and then I multiply this out. That's going to be a squared minus b squared all over the common denominator. I'm sitting here worried about how much room I have to work these. All right, so multiply that, and then I got a parenthesis there. And then I've got a squared plus 2ab plus b squared minus a squared minus b squared. And that's all over a minus b times a plus b. All right, so combined like terms, we got 2a squared, the b squareds cancel out, and that's going to be plus 2ab over the common denominator, a minus b times a plus b, divided by, and then we've got, let's see, the a squareds go out there, a squared minus a squared, and then I've got, let's see, 2ab, and then b squared minus negative b squared is plus b squared over a minus b times a plus b. And so then what we want to do is we want to factor the numerators. So let's factor out a 2a, and that's going to leave me with a plus b over a minus b times a plus b, divided by, and then we're going to factor out a, oh, I messed that up. That's 2b squared. B squared minus negative b squared is plus 2b squared. All right, so let's factor out a 2b, and that's going to be left with a plus b over a minus b times a plus b. All right, and so now we can see the a plus b's cancel here and here, and I'm left with 2a over a minus b divided by 2b over a minus b, which that's equal to 2a over a minus b times the reciprocal, a minus b over 2b. And look at all that cancels out. And we're left with just a over b. And there's your answer to number 5. All right, just hang with me. We only got 2 more to do. All right, let's look at problem number 6. All right, so here's a equation to solve. It's actually pretty easy, isn't it? So we're going to multiply through by the common denominator, which is 16. So that's going to give me 8x. I'm sitting here multiplying through. That's going to be 8 times. Come on, let's get this right. 8 times 3x minus 4 minus 2 times 6x minus 5 equals 3x minus 1 equals. All right, so that's going to be 24x minus 32 minus 12x plus 10 equals 3x minus 1. And so that is going to give me, let's say we got 24 minus 12 is 12x minus 22 equals 3x minus 1. We're going to subtract 3x to both sides. We're going to add 22 to both sides. And so we're going to get 9x equals 21. Divide everything by 9. And we're going to get x. That means x equals, let's see, 21 over 9, which is 7 over 3. And there's your answer. All right, we got 1 more to do. All right, so here we go. We've got the last problem, number 7. It's just a system of equations. So we'll use addition method to solve it. So we can multiply let's multiply the first equation by 3 and the second equation by -5. That'll give us -15 and +15, and the y's will cancel out. So when we do that, we get 21x minus 15y equals, what is that, 72? And then we get -20x plus 15y equals -55. And then what do? We add. And so that's nice. We get x is equal to 17. And then we can take the 17, plug it back into any of the equations. I'll plug it into that one since the numbers are the smallest. So that's 4 times 17 minus 3y equals 11. So that is going to be what? 68 minus 3y equals 11. Subtract 68 to both sides. We get -3y is equal to -57. And then divide everything by -3. We get y is equal to 19. So we get 17, 19 is our solution. So that was a MIT Algebra entrance exam, 1969 to 1970 algebra is what it says. So fairly easy. So, let me know how you did in the comments. If you paused the video and took the exam, did you get them all right? Would you have passed the entrance exam? All right, so I hope you enjoyed that video. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.